Hey folks, so this is the polar bear problem from the projectile set. It's about a maximum height or the vertical of the polar bear. It's a silly problem. I drew a beautiful picture of a polar bear here that we're going to analyze. And I drew like a bigger picture of trajectory. This question concerns the topic of maximum height. And so any projectile that's launched upward at any angle is going to have a fixed maximum height that it can reach based on the initial vertical velocity and the acceleration due to gravity. So that's what this is concerned with. So I've imagined the polar bear as a person-shaped thing jumping off the ground at some angle, um, and the polar bear like travels up in the air at some point. And so, a polar bear is a large creature, and you might ask like, well, where do I measure the vertical? Maybe you would measure the starting point as maybe the polar bear's like top of its head, and then the vertical would be measured from the top of its head to the ground. You could also do the same thing with the polar bear's like feet. Um, and or pause rather, and so you could do it that way. But whatever way you do it, it's a certain amount of change in height, and it's easiest if we just imagine that the starting location of the polar bear is 0 meters. Everything's easier based off of that. So we can imagine that it's going to be from the ground, and then that their like feet are actually going to make it up here. So this vertical has a special kinematics set of data. We talked about how you have a projectile launched at an angle at a certain speed, and that the horizontal speed doesn't change, but the vertical speed does. At that maximum height, it is the maximum height because that object used to be moving upward, but acceleration due to gravity has slowed it to a stop, and it is still moving, it's still moving, but it's no longer moving up, and it hasn't yet started to move down. So that is the moment where the vertical velocity is equal to 0 meters per second. Now keep in mind that it is only the vertical velocity. The horizontal velocity is still equal to whatever it was at the beginning of the launch. So it's only the vertical velocity that's zero. A big conceptual question that you want to pay attention to is that at the maximum height of a projectile, its total velocity is equal to its horizontal velocity. So the velocity at that moment is equal to whatever its horizontal velocity is because it doesn't have a vertical velocity. So that's a concept based around maximum height. Okay, so as far as the polar bear is concerned, we want to do a little bit of trig, and the convenient thing about this is that we don't need to worry about the horizontal direction. Okay, so the polar bear leaps with a really small speed, 0.64 meters per second. And then the vertical component of that speed would be that number times the sine of 45 degrees. Now 45 degrees is a nice angle. It essentially means you only have to do the trig once if you want to, because 45 degree, a triangle that has a 45-degree angle and is a right triangle has two sides that are the same length. So this Vy naught, which is 0.45 meters per second, also happens to be Vx naught, but that's not important in this problem. So that's our starting value, and then we want to know how high off the ground it makes it. So again, I'm not making the chart, but I know the initial position is 0. I know the initial y velocity. I know the acceleration, and I know the final velocity. And so the equation I'm going to choose is this one. This is a generally useful um, maximum height equation because it doesn't involve time. You can also use the one that involves time. You just have to then use a different equation. So the way this gets filled in is I have 0 meters per second, that's squared, equals 0.45 meters per second, that gets squared, plus 2 times negative 9.81 meters per second squared, times y minus y naught. And so y naught is 0, and so that's just going to be times y. So I would do 0.45 squared And so I would simplify this to 0 equals 0.2048 equals, or no, sorry, not equals, minus 19.62 times y. And so I would just solve that um, by subtracting both sides by 0.2048 and then dividing by negative 19.62 to get a final value of y of 0.010 meters. Okay, so the vertical of the polar bear is 1 centimeter, which is not unrealistic because how often have you seen like a nature video of a polar bear jumping? So there we go. So that's a maximum height problem. You can do a maximum height problem from any starting situation. It's just the one thing you want to focus on is this vertical velocity is 0 once you get to the maximum height. And that is that.